Witkowski, who lives in this part of the world and is pretty well known in wireless circles. He goes, I think, to every meeting there is about wireless, and from what he tells me, there's a lot of meetings. So this panel is about LTE U versus Wi-Fi and the battle for who is going to get to dominate or coexist, the technologies that will dominate or coexist on 5 gigahertz. I'm going to let him introduce his panel because I don't know the panel members very well, but I understand that basically their format is they have a short presentation, each one of them, and then it's going to be followed by moderated questions from Mr. Witkowski. So here we go.
Thank you, John. So welcome. I'm David Witkowski. I'm the founder of Oku Solutions, which is a local professional services company. I am, briefly, my background, I am the executive director of the Wireless Communications Initiative for Joint Venture Silicon Valley, which is a nonprofit here in the Bay Area. We've been around for 23 years. We interact with local companies and cities to try to build partnerships. Our goal to make the wireless networks in the Silicon Valley be the best that they can be. I'd like to apologize for the fact that we have 3G coverage in this room. It's horribly embarrassing for me when this happens. We're in the Silicon Valley, and I could throw a rock and hit Apple. We should have the best coverage, and we don't. So that's essentially what I am working on fixing. So our panel today is we're going to talk about something that's specific to emerging technologies that are coming into the UNII, the 5 gigahertz band. And the dominant technology there for many years, I mean, I'm thinking back to having gone to the WinLab conference in Long Branch, New Jersey in 1998, where the UNII band had just been created the year before. And at the time, you know, Wi-Fi had just come out. In a few years prior to that, the FCC said, well, let's have some more unlicensed spectrum. And the only criteria for using the band was it had to be digital and it had to remain within the power limits that were set forth. They never said anything about what was going to be used, because I don't think anyone had thought at that time that it might be used for you know, potentially conflicting services. So the forcing functions on this are that we are seeing an exponential increase in the amount of mobile data that's being used. Should be no surprise. You see everyone using their phones. I was walking through downtown San Jose. My offices are in downtown. And I'm watching the endless parade of people going down the sidewalk with their phones. And they're on the buses, and they're streaming video, and they're watching YouTube and Netflix on the buses. You know, the cost for that spectrum is extremely high. In the AWS-3 auction, it was something on the order of $49 billion just for a small chunk of spectrum. We expect that the 700 or the 600 megahertz auctions will be even more expensive. So carriers that want to roll out spectrum to support the devices that we're using, obviously they're putting a lot of investment in to make that happen. Then unlicensed spectrum potentially available to them seems like a pretty good deal. If we took the AWS-3 rate, dollars per megahertz pop across the entire United States, multiplied by the amount of spectrum that's there, I calculate that the value of that spectrum is $138 billion, which is 3 times more than they paid for the record-setting AWS-3. So of course, there's a financial incentive to put LTE signals into the 5 gigahertz band. There's not a lot of viable spectrum outside of that. We've talked a little bit this morning about the 3.5 gigahertz, the Citizens Broadband Radio Service, but there are complexities in using that. Unfortunately, it was intended for use by small cell, but this notion of a spectrum database, it's still to be proven. Maybe there are some technologies that'll support that, but today that spectrum can't really be used for small cell. And in the short term, the carriers are looking for spectrum. So it's really, I like to say, at the end of the day, it's about the spectrum, full stop. If you can get spectrum to roll these things out, you can make money. Mobile data, just a quick chart here. This is from a report that I published earlier this year. showing the mobile data traffic growth. You'll notice that we're beginning to reach the point, mobile data on a per month basis, and that vertical there is in petabytes. All right, so that's over 70 exabytes of mobile data per month 5 years from now. All right, we all know Shannon Hartley, and we all know what that means. So you got to have the bandwidth, barring a heroic increase in the amount of technological sophistication to put spectrum into a certain bandwidth. But we reach a point where you just simply don't have enough bandwidth to do what we're going to want to do with the mobile networks. So in the 5 gigahertz band, we have emerging users. All right, so 5 gigahertz has traditionally been used for enterprise. It's been used for campus. You go down to Apple, you go to Google. Most of them are running their corporate Wi-Fi on 5 gigahertz. We're also seeing that it's used for critical infrastructure, point-to-point links along gas power lines. Traditionally, it's been a Wi-Fi usage model. There hasn't been anything else in there. A few cordless phones, not too much else. We are seeing an emergence of a business model that's called Wi-Fi first. Okay, so what Wi-Fi first is, who's heard of Google Fi? Do you know what Google Fi is? Okay, so Google Fi is the Google phone that prefers to use Wi-Fi if it can, and only roams onto cellular, traditional telecom, if it can't find a Wi-Fi signal. They're in New York City. Folks from back east, you've heard of Freewheel. You know what the Freewheel service is? Freewheel service, Cable Labs, Cablevision. All right, so Cablevision has a Wi-Fi only model in New York City where you can get a handset that never touches a cellular network. It's only Wi-Fi, because why? In New York City, you have tons of Wi-Fi networks. You have Cablevision networks all over the place. You can get onto them, and that's your carrier. Wi-Fi is your carrier. Now, this doesn't necessarily work here in suburbia, but it can work in dense urban cores. So we're seeing an emergence of the Wi-Fi only. Hotspot 2.0 deals are beginning to emerge. We're beginning to see movement towards Hotspot 2.0, which means that if you have at home, you have, say, Cablevision, and then you go here to California and they have Comcast, your phone would automatically roam onto a Comcast Wi-Fi. So potentially now you have the ability to have a Wi-Fi only mobile service that you can then use Wi-Fi networks in other parts of the country, and you don't touch the mobile networks, the traditional big four carriers. Comcast is doing this, Time Warner, and then the problem, of course, is that Wi-Fi is perceived as free, right? We think of Wi-Fi as free. We don't think of it as a paid model. Although we pay for it for a set price for our home broadband, we don't think of it as something that we're going to pay based upon the amount of usage that we have. Wi-Fi is usually given away. We come to the hotel, hey, free Wi-Fi, great, I'm going to log on to it. So there's an economic perception there that has to change. There's other emerging users in the 5 gigahertz band, and this is the source of the topic today. There are technologies, LTE technologies, which are currently in planning to be used in the 5 gigahertz band. So everything I've just talked about, now suddenly there's a sharing question that occurs in there. LTE signals in the 5 gigahertz band. Well, what happens when they start interacting with the Wi-Fi? Do they coexist? That's the question that still remains to be seen. Was just having a conversation with some of my panelists today where we were asking, well, what's going on with the testing? They've proposed some limited trials, but the FCC has been tracking this very closely, because while there is not an expectation that Wi-Fi owns this band, there's certainly an expectation that there would not be interference to existing systems and potentially harmful interference. So there are, for example, there's hold off. If you sense another signal at a certain power level, then you back off and you wait your turn. So the question is how polite is LTE unlicensed? And that's really the question that is being debated right now, and there's been a lot going back and forth on this, and I'm constant updates on this in the industry. So the two technologies that are emerging are LTE U, LTE unlicensed, and LAA, which is an evolved form of LTE U. and then LWA, which is Wi-Fi under control of the LTE core. So it uses it, and so if you hear the term offload, Wi-Fi offload, that's essentially what LWA is. These are the revenue models that we did for the publication earlier this year. You can see that the Wi-Fi service revenue is there, and the savings from offload are huge. So this is what's driving the interest of the carriers to go to LTE in the unlicensed band. But Google published some results in an FCC filing. There was a big FCC filing earlier this year. This is a chart of Google's results. And if you look at this, you can see that there's a point at which that Wi-Fi throughput goes to 0. So of course, this is Google, which has a vested interest in Wi-Fi, publishing results. Are they being fair? We need to test that. Other companies need to look at this. But you can see that in certain cases, it can be shown that LTE does knock Wi-Fi off the air. So that's what today's panel is going to be all about. So I'm going to have 3 panelists, some gentlemen that I've worked with in the past here in the Silicon Valley. Clint Brown from Broadcom, Amit Jain from SpiderCloud, and Jack Unger from the Wireless ISP Association. We're going to really go through these slides quickly to try to get to the point where we can have some questions with you. I'm going to ask each of them to come up individually, do a very quick presentation. We'll do a moderated panel, and then we'll give you folks a chance to ask some questions. So without further ado, I'm going to ask Clint Brown to come up and talk.
Hi, I'm Clint Brown. I work for Broadcom Corporation. I've been in the Wi-Fi group there for many years, actually since its beginning in the early 2000s. I'm also the vice chairman of the Wi-Fi Alliance. So I've just got a few charts here. So I think David just went through this. This is basically the difference between LTE U and LAA, so we won't spend too much time on this. I think here I just want to make a couple of comments. One, there's been, almost 10 billion Wi-Fi devices shipped in history here. It's a lot of devices. David went through the number, the data piece and the offload piece, and some recent data from ABI suggests that 83% of all data that's sent to Android handsets flows over Wi-Fi. So the way to think about that is the offloading has already occurred, okay, in a sense. About 4.5 billion devices are in operation, is the best estimate we can come up with. And a lot of those devices now are operating in 5 gigahertz. As we know, 2.4 has been very crowded, but since the existence of modern smartphones, dating back 5+ years now, they've all been dual band. And the same situation with many of the routers that you buy for your home, and certainly routers that are deployed by companies like Cable Labs and Comcast and others. So we also have kind of a densification scenario going on with Wi-Fi. It's certainly gotten much better from 802.11b all the way out to where we are today at 802.11ac. But on the horizon, work is being done in the IEEE around 802.11ax. Some of the goals that were set were to increase the speed by 4x, to deal with the overlapping BSS problem so we could really enjoy very dense, efficient Wi-Fi networks. And that work is underway today. So kind of when we think about, as David pointed out, when we think about 5 gigahertz, Wi-Fi is well established there. We've got another technology coming in, LTE, and so this idea of politeness is very important. It's no different than if I was to visit one of your homes and I would observe your customs and your culture and be polite. So what we're suggesting here that's very important, and kind of what Wi-Fi does today, is we want to make sure that these transmissions listen before they talk. This is something that Wi-Fi does today. We want to be able to detect, the bullet on the bottom, I'm jumping around a little, we want to be able to detect very low-level signals. This is one of the challenges with LTE U. It can only detect signals natively down around minus 62 dB. And that's because it came from a licensed spectrum, right? It was almost like a race car on a custom racetrack, whereas Wi-Fi is kind of like our own automobiles on the public highway. So Wi-Fi, there's a lot of Wi-Fi activity that occurs below minus 62. In fact, the data might suggest as much as 80% of the traffic on Wi-Fi occurs below minus 62. So LTE could come on, doesn't hear anything up to minus 62, and it starts to transmit. And its transmission behavior, again, LTE U, is time-based, whereas Wi-Fi's transmission behavior is listen before talk, CSMA CD, collision detection, and then exponential back off if there's a collision and a retransmission. So they're really different characters. So what we're saying is the LTE U Forum, who's a group of small companies who kicked off this idea of LTE U and 5 gigahertz, really needs to think heavily about these politeness mechanisms. Whereas David mentioned LAA, that work's actually being done in an official standards body called 3GPP, where many stakeholders can weigh in. And it looks like LAA may be adopting some of these same politeness mechanisms. With that, I will close. Thank you very much.
So next we'll hear from Amit, Jain from SpiderCloud Wireless.
Good afternoon, and thank you very much for having me here. I'm just going to take maybe a few minutes and try to answer the question of why mobile operators are trying to do LTE. Because sometimes we all wonder, we have Wi-Fi. Wi-Fi is a perfectly good technology. As Clint talked about, there are hundreds of millions of Wi-Fi clients around the world. So it raises the question, why bother? Why are people trying to create this LTE and unlicensed technology? So I think as David had mentioned, the demand for mobile data is growing rapidly. We all see that. We are all aware of it. And right now, lots of different service providers are trying to figure out how they can deliver their services to their customers. So, of course, mobile operators are in the game. They have got their cellular networks. They're trying to use Wi-Fi. Comcast, Cablevision, all the big cable operators. Outside the US, folks like BT have millions of access points and the public access points in the UK. And then you have the big internet companies like Google and Facebook jumping in and saying, hey, we're going to build Wi-Fi as well. So if you look at the overall trend, there are lots of very large companies who are all trying to figure out how do we use unlicensed bands to deliver our services to our customers, and of course make some money off it. That's the basic thing that people are trying to address. So the challenge that now all these companies face is that Wi-Fi is perceived to be free. We all know that there is nothing in the world is free, but if you use a free Wi-Fi access point, you're probably sharing your private information. You're providing information about what kind of which website you're going to, or things of that nature. Sometimes Wi-Fi is available bundled with other things. So if you go to Starbucks, you get free Wi-Fi, but you buy a $3 cup of coffee. You stay at the Hilton, you get free Wi-Fi, but you pay $200 a night. So the way Wi-Fi becomes free in many of these settings is that it is bundled with something else, and then Wi-Fi becomes an amenity. Now this leads to a challenge for a lot of wireless operators, the normal big four wireless operators in the US, because you don't expect Verizon or AT&T to be taking your private information about your web surfing and then converting it into ad dollars. In fact, a couple of times in the past when some of the big carriers tried to do it, they got under a lot of legal pressure to stop doing that. So when you get onto to a carrier's network, you expect that you're paying them whatever you're paying them every month, and in return you'll get a high quality, reliable, secure, private connection. And that is why the normal ways in which people have monetized Wi-Fi have not really worked for the wireless operators. So right now what they are trying to do is to make their usage of unlicensed band look just like LTE, the service for which they are charging you. And they would like a system in which when they go out to the subscriber, you're getting LTE, you're getting service, which is 4G or LTE, and then it is delivered to you over a number of different frequency bands. It could be frequencies bands, spectrum that they actually own, or it could be unlicensed spectrum when available. So that's their motivation in trying to develop this technology called LTE. The second benefit that the operators have is that LTE integrates in their network just like their normal LTE network, just like all their licensed spectrum network. So it is it's much easier from a network integration perspective. I'm just going to use one of my company's product pictures to just illustrate that point, and then I'll hand off to Jack. So at my company, we build these small LTE base stations, which we call small cells, and they're used to provide LTE coverage inside buildings. Now, our LTE base stations connect back to this picture on the right, which the operators call their core network, where they terminate the traffic, they authenticate users, etc. And when we actually build base stations that now support the unlicensed, when we support both the licensed and the unlicensed band together, there is absolutely no change in the network architecture. So from the carrier's standpoint, using unlicensed bands becomes as simple or as straightforward as the way they use their licensed bands. So that is the other attractive part from their standpoint, to make the usage of unlicensed bands similar to the way they use the licensed bands today. As Clint mentioned, there's a lot of discussion right now on how the two technologies, Wi-Fi and LTE, would coexist. And I think those discussions would continue for a while. We have lots of ideas. I personally feel that these problems would be solved. We're quite optimistic that this would work out between all the players in the industry. And I think only after all those problems would work out would you start seeing this technology in the market. Thanks. Jack.
Okay, so next we'll hear from Jack Unger from the Wireless ISP Association. Obviously a group that's a big consumer of Wi-Fi bandwidth.
Okay, great. I'm going to proceed quickly, but I want to thank the Radio Club of America for your support of amateur radio over the years. I'm K6 X-Ray Sierra. I've been a ham since 1958. And today I work with the Wireless ISP Association as their FCC technical consultant to co-write the FCC filings. So without ham radio, I certainly wouldn't be able to be here today or do what I'm doing. Let's look at these quick slides. I'm perceiving a war of unlicensed being overrun by licensed. Now, I know as hams, we are always concerned that unlicensed in bands that we've been using is going to overrun us as amateurs, but the same thing is being felt by the unlicensed users, the wireless ISPs that are providing broadband internet to about 4 million people in the US right now using shared ham bands and unlicensed frequencies. We're concerned our ability to continue to deliver the internet is going to be taken over by licensed interests, which, by the way, I'm jumping ahead here, but when you buy internet access, it costs roughly 10 times as much to buy it from a mobile broadband company than it costs to buy it from a fixed wireless broadband company like a wireless ISP. So if they take over completely, we'll all be looking forward to paying 10 times as much for our internet access, although that price may come down. Let's go back to the slide. In all of the unlicensed bands, we're seeing pressure interference, which is slowly decreasing our ability to use the unlicensed frequencies to provide broadband internet. The 900 megahertz band is under pressure from a licensed company called Progeny. 2.4 is under pressure now from Globalstar. 5 gigahertz, as you know, is under pressure from LTE. Nothing wrong with LTE as long as it's, as has been said, as long as it's polite. If it coexists, fine. Will it coexist, though? 3550, as David mentioned, is a new emerging 100 megahertz band, and everyone's hoping to play together nicely in the band under the control of what's called the Spectrum Access System, SAS, which is an online database that is supposed to manage all of the frequencies and mitigate interference. It's a wonderful concept, intelligent spectrum management, but we're all working together to get it to play out, to create it in a way that it actually works. Let's see. I like to characterize, I hope I'm not being unfair, LTE U without the ability or the deployment of mechanisms that cause it to share the band with Wi-Fi. I characterize it as a broadcast technology because it downlinks to the cell phone in unlicensed, but the cell phone talks back on a licensed frequency. And the cell phone is controlled by a licensed mobile broadband network. So whereas Wi-Fi has to listen and talk in unlicensed, LTE U is looking right now just to broadcast, just to transmit in unlicensed, but not to listen. Now, some of the coexistence mechanisms do involve listening, but many of these coexistence mechanisms are not required to be used in the US. Okay, now, can I go forward, or will I go in reverse when I push this button? Okay. So we all know that 5 gigahertz is used by many, more than just toys. That's obvious. It's used for serious purposes. We all know that. 3.5, now closer to 4 million people rely on unlicensed spectrum, mostly 5 gigahertz to get their broadband at home. And of course, the critical infrastructure industry, water, power, sewage, who else? The stuff we need to make our homes run typically run their long-distance networks with unlicensed point-to-point links. So it's important that we all work together to make sure that unlicensed spectrum is not overrun by licensed interests. Okay. It's fashionable to say LTE is more efficient. It's definitely more efficient in the sense of bits per hertz. It's more costly because obviously the license costs need to be paid for somehow. And mobile technology, the mobile broadband costs, the network, the cell sites need to be paid for. So of course it's going to be more costly. But we don't want it to kill off unlicensed. And so LTE is clearly more efficient at extracting revenue from our wallets because it basically has to survive. I'm not justifying it. I'm simply saying let's work together to make sure LTE U plays nice with everyone else. That's all. We look forward to your questions.
Thank you, Jack. I want to time check here. Since we started a little late, I didn't quite get a read.
We're about 28 minutes.
Okay, so I've got about 15? Yes. Okay, fantastic. So we'll do, I'm going to do some moderated Q&A. I see a hand in the back, so I know we've got audience questions, but I want to do a couple of Q&As. So from the panel's perspective, I mean, recent updates, this situation is evolving rapidly. I was hoping that the panelists would each give a very quick update on what's the latest news you're hearing. Of course, things you can talk about publicly. I mean, you may be aware of things that you can't talk about. But what's the latest news on coexistence? How is that going? You, Clint, mentioned some testing that occurred recently.
Yeah, the Wi-Fi Alliance had a workshop about
Do we have a microphone?
two weeks ago, and about a week ago, Qualcomm and Cable Labs released some test data. They had been asked to work together by the FCC. And there's reports out there that you can read about that. What was interesting is they were definitely not in agreement with respect to where the status of coexistence is between 5 gigahertz Wi-Fi and LTE U. The FCC is watching things very closely. They actually sent a representative to the workshop that the Wi-Fi Alliance had. And so we'll just have to see what happens here over the coming months.
I think that's fine.
Okay. All right, great. Thank you. So, of course, you know, we always hope that the government won't get involved. I mean, what do you what do you think is going to happen? And we probably ought to just leave the microphone down here because I'm going to be, the panel's going to talk, and I would just have them pass the microphone around. Do you want this microphone, by the way, for audience Q&A? Or? Oh, okay. What is, I mean, just a guess. What is the likelihood that we're going to be able to resolve this without the FCC's involvement? Do you want to?
Well, I think the industry and the FCC have been pretty clear that this is a market level problem that needs to be solved by the players in the market. And I think everybody seems pretty comfortable with that path if, of course, it works out.
Okay. Some thoughts?
Yeah, I might diverge a little bit from that. I think the FCC will need to be involved because if we leave it entirely to the market, quote unquote, the largest players will prevail, and that concerns me.
Yeah, I would say there are large players on both sides of this debate. So just like the big mobile operators are trying to get, or some of the big mobile operators, not all, are trying to get LTE unlicensed as a new technology. At the same time, there are mobile operators like AT&T that have millions of Wi-Fi access points in the US right now. There are very large cable companies who are campaigning really hard to ensure that there is coexistence. And then there are gigantic internet companies, I guess today in market cap valued more than several mobile operators like Google and Facebook, who are trying very hard to make sure that Wi-Fi remains available. So the interests are, I would say, evenly matched at this stage, and I think there'll be a decent market-based solution to this.
Okay. So taking another perspective on this, according to the rules, LTE could do whatever it wants in this band, as long as it's not intentional interference. I mean, it is a Part 15 service. If you are digital and you remain within the power mask, right, you're legal. So if we don't change the laws, and as long as it can't be proven that LTE unlicensed or LAA is intentionally interfering with Wi-Fi, what standing do we have? So taking that perspective, I'd like to ask the question, well, why can't we do this?
Yeah, so one thing at least that you see in most FCC, the way FCC has looked at stuff or regulations in the US is that new services should not hurt incumbent services. Mm-hmm. And this is a principle that has been followed multiple times in the past. And I think that is the basis for, since Wi-Fi is the incumbent service, as are a lot of the other devices that are functioning in the 5 gigahertz band, there is a requirement to make sure that there is nothing adverse happens to it. Now, of course, the spectrum has to be shared, so it would affect the total capacity that you're delivering over Wi-Fi. But as long as both the technologies are coexisting, I think that would be the rule.
Okay.
Yeah, of course, the definition of coexist is really, I think, the issue. What does coexist really mean? Do all parties will all parties be allowed to live fully or function efficiently, or will some be more vibrant than others?
So Julius Knapp from the FCC had asked the LTE U forum, why did it choose minus 65, minus 62? I think you said it was minus 62. I thought it was 65, but 62. So Julius Knapp asked the question to the LTE forum, why minus 62? Question then becomes, is that likely to change? Or do you see the LTE forum listening more aggressively in order to avoid that level of interference? Do you think that's coming?
Well, I think it's too early to tell. I think that particular topic is firmly on the table. Mm-hmm. I think everybody knows it's a problem that needs to be addressed, and I think the question will be, will it be addressed?
Okay. Other comments? Okay. Let's talk very briefly about the CBRS band, the 3.55. I mean, what is it going to take to move that forward? If we had the 3.55 band and we could get past some of these hurdles, Jack alluded to the fact that the FCC had said it was going to be a licensed and unlicensed, and that licensed portion's been addressed and the unlicensed portion has been tabled. What's it going to take to move CBRS forward? And how do we make that happen? If we had it, maybe we could depressurize 5 gigs.
Yeah, because LTE is looking, of course, at 3.5 gigahertz as well as 5 gig. But CBRS, Citizens Broadband Radio Service, 3550 to 3650, controlled by this spectrum access system that'll, in theory, could pick your frequency, although it wouldn't necessarily have to. The FCC has punted a little bit on the further evolution of the SAS system. And the FCC said to industry, well, we don't want to set standards. We don't want to limit you by telling you what you have to do in every regard. You guys, you industry guys, go out and figure it out, figure out the details. So this is being worked on today in an organization called WinForum. And it's most of the large players and many of the mid-sized players, and WISPA is even a member now recently. So here's where all the engineers are coming together and kicking around all of the technical details about how the intelligent spectrum management, the SAS system, can share both between licensed users and unlicensed users without anyone without the licensed users being stepped on. Okay? It's coming along, I think, fairly well in WinForum. I'm kind of encouraged by the open-mindedness that I've perceived on the part of most of the participants.
Do you anticipate that maybe resolving in 2016?
I think it's going to take, it'll be beyond 2016, I think, before all of the technical details are really hashed out. Plus, there's the FCC requirement. See, 3550 3.5 is also shared with existing government Department of Defense users. So they have priority over new small cell users and new unlicensed users. So they are requiring that what's called an ESC, environmental sensing capability, be built into the SAS. In other words, if they're on the air, say in San Francisco Bay, then no one else will be able to use the frequencies that they're using. So that's an even more interesting sharing environment. It's government, it's mobile broadband, and it's fixed broadband, and critical infrastructure industry, all working to try and make this spectrum sharing be efficient.
Okay, thank you. Time check? Okay, perfect. We had questions from the audience. Do we have microphones for the audience? And then the panelists are probably going to want to talk. So let me do this. I'm going to turn my lapel over to the audience, and I'll use the podium mic. So you guys folks share that. Gentleman in the back had his hand up first, and then we'll go around.
Yeah, so I have 2 questions. Not being an engineer, there are 2 things that haven't been really discussed here, and that is, number 1, the public safety has 50 megahertz at 4.9 gigahertz of spectrum, and we've learned over the past few years that that doesn't penetrate walls and buildings well, and it really is not very good for mobile technology. You can use it for local area outside networks and things, but going through walls and things doesn't work. So why would this 5 gigahertz be any different? And the second thing is, I've always been under the impression that Wi-Fi is not a mobile technology. In other words, explain to me, how does this hand off? If I'm sitting here using it, that's fine. But if I walk outside and I don't have this signal and I'm trying to get the next one, I got to keep signing on. So how does that get managed in this scheme of things?
I'll take your last question first. So the Wi-Fi Alliance established a protocol called Passpoint, and this makes the signing on, the association process that we're all kind of used to, automated. So imagine just as you roam from one cell site to another, because your phone has credentials that allows it to do that, the same thing would essentially occur at a very high level between one Wi-Fi access point and another. With respect to your first question, and I think Amit said this earlier, the small cells are being put really indoors, okay? They're being put indoors because cellular also has problems reaching indoors. David made a comment about 3G in the room here. So small cells are put in airports and in enterprises to fill in the gaps that typical LTE cellular network cannot support.
I would just add one thing that in the case of when we talk about LTE and unlicensed, it is not actually LTE running in the unlicensed band only. So whenever LTE and unlicensed, the way LTE and unlicensed works is that you always have a licensed channel, and whenever the licensed base station needs basically a little more spectrum to send the file over, whatever you're downloading over to you, that is when it supplements the licensed spectrum with unlicensed spectrum. So the unlicensed is only being used as a supplemental downlink in this mode. And this means that, let's say if you're on a so-called LTE U base station, your connection would always stay on the licensed spectrum LTE channel, and that's where all the mobility aspects would be handled. And beyond that, I do agree with Clint that it's really might be an indoor technology most probably.
Very good.
Yeah,
You have the
I
mic.
understand that some of the 5 gig frequencies are are part of the ISM band, and if that's the case, if you get interfered with, it's tough luck. You can use these frequencies for two-way use, but you have to accept any interference, which would lead me to believe that the more robust formats would be the winners, and there'd be no reason for the more robust formats to negotiate with the less robust formats. Because for like LTE downlink is probably more robust than the Wi-Fi.
I think it's generally accepted that LTE is more efficient. However, I don't think that it's the case that you can, and that was what Amit had said, was you can't just, come up and presume that you're going to get it because you're better or stronger. I mean, there is a presumption of incumbency, that you have to be polite to incumbent services. So I think that the crux of the issue is where do you verge from legal to illegal in that Part 15 definition? That's part of what we're struggling with.
Well, I actually heard a slightly different comment, because I think the gentleman with the microphones kind of accurately summarized the problem at the high level. And I mentioned this earlier when I was speaking. Wi-Fi tests and then communicates. If it collides, it backs off, sometimes exponentially, and then retransmits again. LTE is solely based on time transmission. So when it believes the channel's clear, it starts to use the channel for blocks of time, irrespective of what may be going on. So I think your characterization was correct as it pertains to LTE U.
Okay. Question, maybe get this out of the room.
Real quickly, now, the ISM rules have specific maximum power ratings. Is this LTE going to follow that?
Yes, absolutely. It's all Part 15, and everybody, that you can't get around that.
Okay, and one other quick question. There are currently video cameras that run full stream video 24 hours a day in the 5 gig band. At the end of the day, I mean, these are unlicensed bands. How do you, how do you deal with something like that? In fact, I was involved in a situation where we were at a show and we were offered Wi-Fi by one of the broadband providers, and they had cameras in the building as part of the show. It was a show, and basically the broadband provider went and told them to turn them off, and they said, no, we have every right to use this band as much as you do. I don't understand how one could make a business proposition or a business case in a spectrum where they know potentially they really don't have protection, and I think that's what's been done in the ISM bands. That they're experimental bands. That's what they're there for. They're not really there to produce a revenue model.
Question from over here. I think Ray had a question.
I do want to see.
And looking at the build out, the infrastructure is going to flow a lot faster. What happens then to the legacy equipment that's already occupying that 5.5 gig range?
So maybe I'll try to answer both the questions together. So in the 5 gig band, there are multiple channels. So in a lot of cases, the equipment tries to, whether it's the Wi-Fi equipment or maybe future LTE and licensed equipment, will first try to identify which is the channel that is available. So in that sense, it is not necessary that they will step over each other. And that's the reason why people are excited about the 5 gig band, because you have several hundreds of megahertz of spectrum that's available there. So in that sense, incumbent equipment that you have would still continue to function. Now, what we all would have to deal with is that more people who are trying to use the unlicensed band, everybody would have to share, and that is irrespective of whether we are doing it with Wi-Fi or we are doing it with LTE U. I think to your example, if you're in that convention center where there is the video camera, which is running on Wi-Fi, that has to now somehow share the spectrum with, let's say, whatever application you were trying to use in that convention center. So sharing, I think the sharing idea is in unlicensed is not dependent on technology. I think more users you'll have, the more you'll have to share the limited spectrum.
And are there current rules under the FCC rules to facilitate that?
For sharing?
No.
Not really.
No.
From a customer standpoint, I noticed that my phone battery runs down a lot faster when I'm locked on an LTE signal than when I'm on Wi-Fi all day. And so I'm just wondering if customers would prefer being on Wi-Fi and having better longevity from their batteries than being on an LTE system and their pockets heating up a lot faster.
Comments from the panel? I think the levels of Wi-Fi we're talking about are lower than the mobile levels.
Yeah, I mean, and Wi-Fi's become much more efficient. But it, in fairness to the industry, you could be in a situation where your LTE base station or tower happens to be a significant distance versus the closeness of your Wi-Fi access point. I've experienced, LTE running down much faster in one city versus another. So I don't think, that's the real issue. It's an interesting point that, because Wi-Fi has become much more power efficient.
Yes, it is an interesting point. And as this gentleman mentioned, we're transmitting at a higher power level typically when we're on the mobile network than when we're on the Wi-Fi network. If we're going further, therefore, when we could go 15 feet instead of 3 miles, which would be the more effective use of that spectrum in terms of sharing.
Right, but I think if the LTE system were in the ceiling of the building, your phone would dial down accordingly. So because you're trying to reach outside, and the phone has to increase its power to make the connection that the battery dies. Wi-Fi is typically close to you within 200 feet. Am I getting?
For outside system.
Am I getting the hook?
We're going to have to cut it off.
Okay.
If you guys would like to talk to the panel, they can go outside. We're going to take about a 7-minute